So a little bit about today's agenda. So we'll be just going through what image preprocessing is and what Pillow is. We'll be learning a little bit about Pillow and its syntax, and then we'll be learning its features and functions. Followed by a short Q&A, and then we'll get on into live coding. So introduction to image preprocessing and Pillow. So image preprocessing is basically a series of methods that we could use on images to analyze them, manipulate them, modify them to our needs. So our main goal is to extract some information from that can be used somewhere else. So basically you can, so either you can find a particular feature that you want in an image after you pre-process it to some degree. So extracting some information would be if you suppose have a picture of a receipt, but it's a little blurry, you can use some image pre-processing to it. You can try to make the image features more sharp and then run it through a text extraction tool, and then you can get the text from that. So Python imaging library, the expansion of PIL, is the image preprocessing package for Python language. So PIL basically incorporates lightweight image preprocessing tools that help us out in editing, creating, and saving images. So the support for Python imaging library PIL was discontinued in 2011, but a project named Pillow was forked from the original PIL project, and Python 3 was added to support it. So now today we know Pillow as the replacement for PIL for future usage, and it supports a range of image file formats, including BMP, PNG, JPEG. So yep, so Pillow. So before that, I'll just see if there are any. Okay, so we're all good. So a little bit about Pillow. So as I mentioned before, Pillow is an imaging library that provides functions for manipulating various image file formats. So it provides a number of factory functions to us, such as loading images, creating new images, modifying an image, manipulating the image, and a lot of other fun stuff. So the basic syntax is to install Pillow. We do pip install Pillow. But when we are using it to import its functions, we say from PIL import image is an example for if we're using the image function in it. So we can basically import the functions we want from it using the from PIL import. So a couple basic functions. So we have image.open to open the image file. We have image.show to display the image that we're currently modifying or the one that we loaded into the work environment. We have image.save, so it saves the image under a given or file name, so you can specify the file name and format in that. We also have image.resize to resize the images. We have image.convert to convert an image from one mode to another. And we have a couple ways to find out the features of the image. So we have image.format to know the format of the image. We have image.mode to show the mode of the image, such as R&B or grayscale or any other format that's there. We also have image. Did I say RGB right? I think I said another word. I'm sorry. Yeah, anyways, image.size shows us the image of the size of the image. So in width into height pixels. We also have image.getPalette, which returns the image palette as a list. We also have functions to manipulate the image, so we can rotate the image, we can flip the image. We also have a way to create a thumbnail, so we can modify the image into the size of a thumbnail version of itself. A lot of fun stuff. We also have ways to apply filters on the image. So like I mentioned, We can sharpen the features, we can blur the features, we can try to extract the contours in the image. We can also sharpen the details. We can also, there are also different ways of blurring the image as well. You can also draw on the image, so you can add text to the image, you can add lines, you can add other figures such as circles and rectangles as well. Okay, so we're done with the basic definitions and features of it. Before we go on to hands-on coding, if anyone has any questions, feel free to leave them in the Q&A chat. And one of us would share the collab link with you guys in the chat, and we'll move on to coding. Awesome. Okay. Thank you, Maitri. So Maitri shared the collab link to you guys. And we'll, okay, so is my screen visible? Can you guys still see the collab page? Yep. Okay. Awesome. Awesome. Okay. So if you're not familiar with this, you could just make a copy of the collab in your own drive. So you could do save a copy in drive. It'll create a copy for you and it'll redirect you into that page. And you can go ahead and use this. You can use this one and you can code along with me. I will zoom in a bit so it's visible for everyone. This should be good, right? Yep, okay. All right, so if you guys have this set up, you could just leave us a thumbs up and then we'll get started with, you know, playing with some images using Pillow. Awesome. Okay, looks like people are getting it set up. So meanwhile, let's connect to the runtime. So even if you just run any cell, that should be fine. But make sure you're connecting to local runtime. Yikes, this looks very confusing. Okay, let's run the first cell, and then we can get started. All right, so we'll be installing Pillow. So the syntax for that would be pip install Pillow, and you can go ahead and run that cell. Okay, and then so we'll be using the image package in Pillow. So package or classes. We'll be importing that basically. So image would have the functions that we'll be using today, and you can go ahead and do that. So we've imported it. We're also gonna import this URL library.request just so that I could get an image off the internet. That's all I'm gonna be using it for. So you could go ahead and run that cell as well. Okay, now to the real stuff. So what we're gonna do is, all right, so we're gonna use this function to import it to load the image. So we're first retrieving the image from the URL. So I've already put in a link for an image, but if you guys have any other image that you would like, such as an apple, oops, not that apple, such as apple, you could go ahead and import this. So all you would have to do is copy the image address, and then you could go ahead and use any image that you want in the place of this URL. I have actually loaded Yoda, not exactly baby Yoda, but I don't want to disclose any spoilers. So for now, we'll just call it Yoda. Okay, so we're gonna be opening this image. We're gonna load the image basically using image.open. So image.open, and you specify this. So what happened was URL retrieved, brought the image in and saved it in the form of yoda.jpg. So we're gonna load it and print it on our screen. So yep, so we have baby Yoda here, super cute. Just a small disclaimer before we go forward. Because I'm doing image over here, that's why the image is showing up on our screen. But if you were doing this on your text editor or on your local environment that's not Colab or Jupyter, you would have to use the function image.show. But because image.show wouldn't work on Colab, we're gonna be doing just image to print it out over here. Okay, so Yoda's with us today, and now we're gonna see what the features of the image that we loaded are. So we're gonna see what the format of the image is, what mode it is in, what the size of the image is, and the palette. So we'll go ahead and run this. So we can see that the image is in a JPEG mode format. It's RGB. The size of it is 1100 into 825, and the palette is none. So usually RGB palettes are none, but if it was other formats, it would have showed us what the palette of it was. So next, we'll resize this image. It's way too big. It's taking me 2 scrolls to get through it. So if we're gonna go forward with playing around with this image, it would just be too big to view in one shot. So I'm gonna make it half its size. So what I'm gonna do is image.resize, and I'm just rounding it to its original size into half. So this would be its width. So that's why image.size of 0. So you can see, right? Image of size has 2 parameters. So we're gonna do 0 will be its width, and then 1 would be its height. We're gonna make it half of what it was. So you do have to do image is equal to image.resize in order to save the resized image. And now it looks fine. It's just a little smaller, but it does fit in my screen in one scroll. So now we have our image resized. That's amazing. Now let's go ahead and try manipulating the image in different ways. The first one would be rotate. So we can rotate it by 45 degrees. So you can see that it's being rotated in its original frame. You could also do rotate 90. And he would go upside, to the left. 180 would make it go upside down. So yeah, you could do a lot with it. Let's try 271 and then we'll be done. All right, so yeah, we can flip it in different, rotate it in different ways. We also have a way to flip the image around. So we can flip it from left to right. So I'll just print the image up here just for reference. Can you use negative numbers and rotate? Well, let's find out. Let's do minus 90. Okay, yeah, you can. Minus 90 is 270, right? So yep, you can. Yep, great question. So yeah, back to flipping the image. Okay, so I'm just printing out the original image here, just so that we could tell the difference between when it's flipped and when it's not. So I don't know, I find this kind of funny, but yeah, so we did flip it from right to left to right. Okay, so the next one will be flipping it from top to bottom, or basically vertically. So this one is flipping it horizontally, this one's flipping it vertically. He's back upside down. So that's a little bit of how we could manipulate the image. And if you want your image to be this way, if you want to permanently make that change, you will have to do image is equal to image.transpose. So we have this image.flip top to bottom. We have image.flip left to right. That helps us do that. And next we can start applying filters to our image. So to use that certain functionality of Pillow, we have to import image filter. So the syntax would be from PIL import image filter. So for this one, I'm loading a different image. It's a skyscraper in Dubai, and I'm just naming it as skyscraper.jpg. I'm also resizing it over here just to the same size of what our baby Yoda was, just so it can be a little smaller and fit our screen. Awesome, so we have our couple of skyscrapers here. Let's start adding some filters to it. So we can do a simple blur. So we can add a simple blur to it. Sometimes this isn't enough and you want to blur it a little further. So you can actually customize it using box and Gaussian blur. So box blur is basically, if I'm not wrong, it would have these rectangles that are blurring the screen, and any number here would specify the size of those boxes. So yeah, let's have 3 or God, should have done a control Z. Okay, so box blur would blur it like this. We can do it a step further. So yep, so this is how box blur works. We also have Gaussian blur, and again, we have to specify a radius for that. And it applies the blur. So you can actually kind of tell the difference here. So this one, you can actually see that it's actually being blurred in like horizontal boxes, if I'm not wrong. Correct me if I'm wrong, but that's what I got from my understanding of it. Gaussian blur is more of, it's a little different from that. You can also have a transition of blurring. So you can have one side of your picture a little less blurred than the other. There is a way to do that. So yeah, so next we would try filtering the contours of the image. So let's just see what contours we have in our baby Yoda image. So for that, it would be image.filter, and then we do image_filter.contour. So these are basically just specifications of what filter we want to use. Okay, so as we can see, we actually can identify that the outer shape of Yoda. I think we could also check it out for the skyscraper. That would look a little cool as well. Let's try that. So let's do skyscraper, filter it, and then we could see what that would look like. Nice. This kind of looks like some sketches people draw. But yeah, so these are the contours in this. And then we could also do some other filters as well. So we can do edge enhance. So it just enhances the edges in the image. So you could actually see how different it looks. So when it identifies the different edges and it makes it a little sharper. We could also try it for our skyscraper, but the image itself was a little high definition. So yeah, so as you can see that the edges of these skyscrapers have been enhanced a bit. So we could also do this on, we could also enhance it a step further. And you can see it's much more distinct. It actually looks like an old magazine. But yep, we could try that again with the skyscraper image. Yeah, so as you can see, it's just a step bit further than the previous one. So it's enhancing every edge that it detects. So yeah, so now we'll see how smoothening of the image goes. So we're making it a little smooth, all the features in the image. So as you can see, it's a lot more smoothened in the literal sense. So just trying it out with the skyscrapers as well. So yeah, it's kind of like it is blurring it. Maybe if we do it multiple times, it does seem a little, it would seem a little blur, but yeah, it's a little smoothened version of it. Maybe if we actually save this picture and try to smoothen it out, it would look a little more mellow, probably. So yeah, we also have smooth more, just like how we could enhance the edges more, so it looks much more smooth than the previous version of it. Yeah. Next, we do have sharpening an image, so you can sharpen each and every feature that's there in the image. So we'll just check that out for a second. So as you can see, when we enhance the edges, it was mostly along all those contours that we found earlier, but this one just sharpens the image overall. So yeah, this would be how we could sharpen the various features in the image, and a combination of all of these techniques would definitely help process the image a little further so we can identify different features and any information that we want in it. And this one, just for a little fun, so we can try embossing the image as well. So it looks like he ran into a block of cement, but yeah, so these are all ways to actually identify how the image goes, and these are all techniques that we add before we actually use these images for any process, like in deep learning and stuff like that. So I've definitely used a couple of these functions as a combination before I did some text extraction, not these exactly, but I did use a couple combinations of these. So all of these do help out, especially when you're very dependent on every minute feature in the image. Yeah, so we could also find the edges of the image uh, using image filter.find edges. So this helps you identify where the edges are in the image. Functions like this did help me out when I was trying to process images of receipts, but there was a lot of background in the image. So usually we take a picture of a receipt and which is lying on a table. And there's a lot of the table that comes into the picture, and that's a waste of a lot of space, especially when we're doing image related machine learning or AI. So you would actually want to crop the receipt out of that image. And so first step to that would actually be identifying where the edges are. So yeah, so that's usually where all of this does come into a lot of help. So we just quickly do it on the um, skyline picture. So as you can see, it did identify that all of that behind so each and every edge that's in the picture, so including each and every floor, it does identify every edge over there. 1 second. I'm very sorry for that. So I'm back now. The last thing we did was we were finding the edges, and our function did that really well. Do the same with Yoda, the find edges one. Okay, so yeah, so it kind of looks like Yoda's walking outside in the dark. So yeah, so he does find all the edges of his main body as well as the mug that he's holding. Okay, so another part to this would be adding text to the image. That's another thing that we would like to do, we would need to do maybe sometime along the way. So for that, we use image draw. So it allows us to draw different things on the image. So it allows us to add text. We could draw lines, circles, rectangles, and everything using it. So the syntax for that, it would be from PIL import image draw, and then we can add some text to the image. So we're gonna add it at 100 into 100 pixels. At that point, we want it to be in all white text. We're adding it to our skyscraper image, and we're adding the text "Hello Dubai." So, yep, so we have it added over here. So we do image draw, and we want to draw on skyscraper. And then using this draw variable, draw that text, and then we add its parameters. So the first one would be the point where we want to draw it. Then we would describe the text we want on it, and then we would specify the the color of the font. We can also customize our font to any specified font format. So this one would be the default one, but you would have to download a specific font format, load it into a variable, and then add the variable name here. I agree. Edge detection is my favorite feature as well. It's super fun. It's super smart. It's just mind blowing how far we've come, and then how cool it looks once we get to do it. So yeah. Okay, so the next one would be concatenating the images. So we can concatenate images horizontally, and we can also concatenate them vertically. Sometimes this would be useful when we want to show the comparison between two images. But I'm sure a lot of us have wished that our phones allowed us to concatenate two images so that we could just have them there and send it. So there is a way to do that with Pillow. So we would the basic logic of this is we create an image, and we call that, so we create a new image of the width of the Yoda image, and then oh, sorry. Yeah, that's right, sorry. So the width would be the combined width of the skyscraper image and the Yoda image. Both their widths are the same because we resize the skyscraper to the width of the Yoda image. So it's basically twice the width of the images we currently have. And then we specify the height as the image's height. So the Yoda's height is what is over here. But as I said before, the Yoda image and the skyscraper image have been resized to the same number. And then, so we paste our first image onto it at the 0, 0 coordinates. So basically at the 0th width, at the 0th height, we are pasting the Yoda image onto our newly created image. And then we're pasting the skyscraper image starting from the width of the Yoda. So like right after the Yoda image, we're pasting that. And then again, no specific height, it will be at the 0th height. And then we're printing the destination image to just look at how it would be. And as you can see, we have them concatenated perfectly. You don't see any black or white overflow outside. It looks exactly right. And we could do the same. Also for vertical concatenation. So over here, we specify the width as the width of any of the images. And then the height would be the combined height of
Hi,
both
Soumya.
images.
I'm sorry to
Yes.
cut you off.
Yeah.
We have a question in chat. So there's a question from Padmaja as the feature behind, is there any algorithm which is being used behind edge detection feature?
Okay. Yes, Padmaja, there is a lot that's written on the back end of this. So deep learning algorithm, I'm not exactly sure what it would be, but there is a lot. There is a way that we could actually code this out from scratch, but I'm not really sure of what actually happens behind it. But I will check it out and get back to you whenever I can. Padmaja always asks amazing questions, and I learned so much from that. So yeah, Padmaja, I'm not really sure what does go behind these, but I will definitely find out and get back to you.
Thank you for the question, Padmaja. Thank you, Soumya.
Yeah, thank you. So we could also concatenate them vertically. So we have image.width. Yeah, like I mentioned, so we would mention the width of the images and then the height, the combined height, and then the same way. So you paste this one at the you paste image at the 0,0 pixel from starting from there, and we paste skyscraper from the 0th width, but from the height of the previous image. And there we go. Clean concatenation. So over here, it was kind of easy because both of them are of the same size. But whenever you do want to concatenate two images, this is a little obvious, but just general guideline, they both do have to be the same size. And if they're not, it would every other gray area would actually be filled up in black. So remember how when Yoda was rotated, the background was black, right? So that would be what will happen with all the extra space. Because this isn't exactly concatenation directly, we're creating an image and we're pasting these pictures on that. So we're creating an image that's black, that's complete, that's just a complete black image, and we're pasting these on that. So that's how that would work. Yeah, so the final one would be creating a thumbnail out of the image. And so for that, we just do image.thumbnail, and that would create a thumbnail of the image. The complete image does get rewritten into that size. So it kind of is like resizing, but thumbnail does it specifically for us. So we can resize it into 19 to 90, and it gets saved into image. So whenever you print image from there on, it would be of that size. And then finally, since this is something that's very useful for us, when we're doing all of this, we would obviously want to save our image. And the way to do that would be image.save. And you can specify the file name and its mode. And you can go ahead and save that. Now you could actually find that it's saved on a runtime. So you could see it's over here. It's been saved. And you could also see how we have loaded and saved the other two images as well. Okay, we have a question. Okay. Which change that was not kept? Which change was that? Arcadia, if you could just let me know in the chat, I can go to that part. So if it's the thumbnail image, then yeah, so thumbnail does change it permanently. But if it's any other function, it shouldn't have. Okay, yeah. Yeah, it does keep it there permanently because we're adding the text onto the picture. So we're adding the text on the picture, so that's why it's permanently there. We can't get the old one back. If you do want to get it back, you should either reload the image, or when you're doing this, you should actually create a deep copy of skyscraper and then do the changes on that. So yeah, I hope that helped. Okay, awesome. Any other questions anyone else has? You can feel free to leave them over here. That would be the end of the live coding, a small intro to how Pillow would work. Yeah, so I do see that a lot of people are curious about what happens on the back end, and I'm sorry that I'm not too sure of what happens, so I don't want to say anything that isn't right. But do join our Slack channel, and we could start a discussion there. I'll do my research, and we could probably have a nice chat on Slack. Yeah. Okay, so we'll go back to our slides, and I'll quickly present. Okay, so just a couple resources that I've used when I was learning how to use Pillow, and a couple of useful websites as well for anything else. And you could also find all the resources in the GitHub repo. All of the slides and the collabs are uploaded there. Okay, so next is we have a couple events coming up. We have the next Python Libraries 101 session on the 16th of October. We'll be doing OpenCV that day. We have a cool session called Less is More, How to Code in Python in One Line. That sounds super, super exciting. We have our LeetCode series study group. I joined the last one. It was super, super amazing. There's so much you can learn from that. If you're ever trying to learn ways of coding smarter, this would definitely be the series for you. We also have Bites and Brew, so you can feel free to register for these on the Women Who Code website under Python events. We also have the speaker of the Coast Series Study Group over here, and she's doing amazing in that series, so you guys should definitely check it out. So yeah, you can find us on our socials. So we're at Women Who Code Python. You can find us on Twitter, Facebook, Instagram, LinkedIn. You could also register for events and join our community on womenwhocode.com/Python. So thank you, everyone. So thank you for joining the session. I hope you guys had fun. I definitely did. So amazing questions today. Truly stumped me at one point, but we can definitely get back on that and have a small discussion. Feel free to scan this code on the bottom right. It's a feedback form, and it would be really awesome if you guys could let us know how we're doing, how we could improve. If there's anything else you can expect from us. We did check out the responses we got earlier, and some people have been asking if there were ways of having a series on HackerRank coding and all. So the LeetCode study group would be definitely for you. So every week they're picking up different optimization techniques. We're going from brute force to optimal solutions. So, and they're using different patterns, different algorithms to solve smarter. So that would definitely be the series for you.